Hello everyone, my name is Rohit Singhal and we were discussing about the hydrocarbons. In the previous class I have discussed about the chemical properties of the alkanes, and in this class we will discuss about the conformations of alkane and how alkanes do look like in 3D picture and how we can imagine in 2D plane. So, let us start with it. Conformations. Okay. So, we all know what alkanes look like. Alkane has a CC bond, a CC sigma bond. Okay. And what happens in a CC bond is there is a symmetrical electron distribution okay. So, there is a symmetrical electron distribution over the CC bond. So, what happens if we will rotate, if we will do some rotation around the CC bond, the electron density around the bond will not be disturbed. So, what happens is rotation around the bond will not disturb its electronic distribution. Okay. So, what we can do means that means the CC bond there is a free rotation without the disturbance of the electronic distribution over the bond. So, there are a lot of arrangements that can be possible, a lot of spatial arrangements as the atoms are as the atoms present in space. So, a lot of spatial arrangements are possible by CC bond rotation. Okay. And these different spatial arrangements are also are only called the conformers or rotamers. Or we can say conformations. So, the difference. So, what are the conformations? Conformations are the different spatial arrangements that can be obtained by a CC bond rotation. So, the different spatial arrangements of the atoms do give us the different conformers. So, however, it is not however, the CC bond is though is freely rotable, but it also has a energy barrier. So, in order to have a free rotation about that CC bond, we need to cross that energy barrier, and this energy barrier is around 1 to 20 kilojoule per mole. So, the CC bond rotation do consist of an energy barrier that is around 1 to 20 kilojoule per mole. Though the energy barrier is not too very large, and the alkanes can have the thermal energy to freely rotate this bond without giving extra energy to it. So, in overall there exist a lot of conformations of the alkanes molecules. Let us discuss about a simpler example, that is ethane. So, let us discuss about the ethane. We know what ethane is. Ethane is CH3 and CH3. Okay. There is one carbon carbon sigma bond, and there is 6 carbon, the 3 carbon attached to each carbon. Okay. Now, what happens is how we can assume the different conformations of the ethane. So, so do assume a ball and stick model. What happens is consider we have to take the 2 center carbons as the as a models to represent. So, what will happen? There are only 2 carbons in the ethane molecule. That is why I have taken a simpler example. So, what we have to do, keep one atom stationary and rotate the another atom and see how many conformations and which conformations are possible. So, what I am saying, this is a CH3, this is CH3. Keep this as stationary fixed and do rotation around this bond and see what different conformations are possible. And as I have already told that the CC bond rotation does not disturb the electronic distribution over the bond. So, there are infinite number of conformations possible, infinite number of conformations possible. However, obviously we can't discuss all the conformations now. So, let us discuss about the two extremes and two useful cases of these conformations. So, two extreme cases are, one is, so I am talking about two extreme cases. One is eclipsed and another one is staggered. Okay. So, these are the two extreme cases, eclipsed and staggered. What happens in the eclipsed case, what happens in the staggered case? Let us discuss about this and how we can represent them in a 2D plane. So, what is the eclipsed? Eclipsed means all the hydrogens, means the hydrogens are close, the hydrogens are as close as possible the hydrogens of two carbon atoms. And staggered means as far as possible. Okay. So, let us discuss this and how we can represent this in a 2D plane. Okay. So, there is a conformation called Newman projection and Sawhorse projection. So, let us first start with Newman projection. There are two projections, Newman and Sawhorse. These are the two projections by which we can project the alkane molecules into the eclipsed and staggered conformations. Okay. Better start with the Sawhorse conformation first. What happens in the Sawhorse conformation? In the Sawhorse conformation, the molecule is viewed along the molecular axis. Okay. So, we all know what projections are, means Newman projection, Sawhorse projection, although this both these two projections looks different in picture, you will see and when I will discuss this. So, these two looks different in the picture, but although we know that the ethane molecule is ethane molecule, the projection is different, means how we are seeing that, or from which area angle we are seeing the molecule describes the projection of that molecule. So, in what Sawhorse projection we see the molecule along the internuclear axis, along the molecular axis. So, what this molecular axis is? There is a CC bond. Okay. So, this is a molecular, means the I is here. Okay. In this direction we are seeing this molecule. So, how this can be represented in a 2D plane? Okay. So, there are two carbons. Okay. Two carbon in ethane molecule. What happens? The front carbon is taken at the lower side and the back carbon is taken at the upper side, and the CC bond is presented by a long line. For example, this CC bond is elongated like this. Okay. And this is the front carbon represented at the lower side, and this is the back carbon represented the upper side. Okay. So, there is a one carbon, this is a carbon carbon single bond, but we will not write carbon here, because as we are seeing into molecular axis line of thing, we can't say there is a carbon atom, there we will show this by a dot. Okay. Now, what we have to do? We have to represent these three hydrogens on both the cases. So, these three hydrogens, what we will have? These 3 hydrogens will are to be assigned in a tetragonal arrangement, means the bond angles need to be the same. We know that the bond angles in a tetrahedral molecule is 109.5 degree. Okay. So, that we have to maintain. So, how this going to take place? 1, 2, 3, means this one is going upside, one is going on the left side, and one is going on the right side, and this CC bond is towards the back side, means I am saying along the molecular axis. So, the back carbon is going on the upper side, and these three lines represent the 3 hydrogens present. Okay. Now, this back carbon arrangement, this back carbon hydrogen arrangements will describe whether the projection will be eclipsed or staggered. Okay. So, what I have told about the eclipse is the hydrogens are as close as possible, means in what arrangements the hydrogen is aligned on the first carbon, the same way on the second carbon, hydrogen, hydrogen, hydrogen. This is an eclipsed. What is happening, that the arrangement of hydrogens on both carbons are in same direction. So, what happens if I have told that eclipse means the hydrogens of the carbon atoms are as close as possible, and that is only possible when all the bonds are going into the same direction. So, if the arrangement of the hydrogens on the both the carbons will be exactly same to each other, then the atoms will be as close as to each other. So, this is an eclipse conformation. Now, how the staggered conformation is possible or forms? So, as we have discussed, as this is the same a CC bond, okay, 2 dots we have represented representing the 2 carbons. Okay. Now, we have to plot 3 hydrogens to both the carbons. Now, keeping hydrogen same onto the first carbon, though we can change on this carbon also, but let us stick to this. We are not changing this carbon thing, okay, but we are rotating this, okay, we are rotating this bond by whichever angle possible. Okay. And now, what happens is, there is a conformation like this we will get. Now, what happens in this? This hydrogen going up, hydrogen going down, this going this side, means towards me, and this is going towards you. This is going towards the away side, and this is going to the opposite direction. Okay. So, all the hydrogens are going opposite to each other. So, hydrogens are what? Far from each other. And in these projections, these bond angles, though is 109 degree 0.5 degree, but in this projection we do maintain an angle of, this is 120 degree angle. Okay. In projections we make the angle of 120 degree. Okay. Okay. So, that is how this eclipsed and staggered conformations, this is a staggered conformation. Okay. And do remember, these lines are inclined. (120 degree) to each other. Okay. So, these are the 2 cases. The staggered conformation is also possible, means till now I have discussed na ki the front carbon I have changed. So, this is staggered. This was the eclipsed. Okay. So, this is eclipsed, hydrogen, 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 hydrogen. in this cases what I have done, I have rotated from going from one conformation to the second, this is staggered. I have rotated the back carbon. Also I can rotate the front carbon. What I will get by rotating the front carbon is this case. Okay. This is also staggered, and both these staggered conformations are same. Okay. It is just the side by which we are viewing. For example, in the second figure, I am seeing it from the front side. For example, someone is seeing from your side, what will see this figure. Okay. So, it is just how from where we are seeing the picture. So, these are the two staggered conformations, but the conformation is only one. These just are the by the way we can see the conformation. The staggered conformation will only be one, the eclipse conformation will only be one. Okay. But we know these are the two extreme cases. Okay. These two are extreme cases, right. But there are many other conformations also possible. In between these two. Okay. And that conformations are called any intermediate conformations in between this staggered and eclipsed are called known as skew conformations. Skew conformations. Okay. So, this we have discussed in this class about the Sawhorse projection, that we have what Sawhorse projection is just the way we see a molecule. It's the molecule is viewed along the molecular axis and can be represented by a ball and stick model. So, what will happen is two carbons are taken, two center carbons are taken, and the hydrogen atoms are arranged accordingly. Two extreme possible cases are there. One is eclipse, another is staggered. Eclipsed means the hydrogens are as close as to each other, and staggered means as far as to each other, giving the two extreme cases. However, we already discussed that the conformation there that the CC bond rotation will give a lot of rotations can be possible, a 0 degree angle, 1 degree, 2 degree, a lot of conformations will be get, and staggered and eclipse we are casing about the two extreme cases. Okay. So, what happens, any intermediate conformations will be regarded as the skew conformations, though there are though there will be infinite number of conformations. So, we can't discuss every one of them. So, we have discussed the two extreme cases of these conformations. The next is the Newman projection, that we will discuss in the later class, and then about the alkenes and their conformations. Okay. Thank you so much.